Quarter 3, week number 2, lesson number 2. The topic is illustrating the need for an axiomatic structure of a mathematical system in general and in geometry. Remember that proving a statement in geometry or in any other mathematical system, it means demonstrating that the statements are in logical order. This implies that only definitions, postulates, or previously proved theorems can be cited to support assertions. There are two types of proof: informal or paragraph, formal or two-column proof. Let's start with the informal or paragraph. Steps in writing informal proof or indirect proof. Indirect proof is also known as proof of contradiction. Step 1. State that the negative of the conclusion of the theorem is true. Step 2. Give the reason from the assumed statement with statements given in the theorem until a statement that contradicts a known fact is obtained. Step 3. Cite that the assumed statement must be incorrect and that the conclusion of the theorem must be true. Practice. Let's say if a triangle is a right triangle, then it has no more than one right angle. This statement is already a theorem. Remember the steps in writing informal proof or the indirect proof? 3 steps to be considered. Let's start with step number 1. We negate of the conclusion of the theorem must be true. From the theorem, if a triangle is a right triangle, then it has no more than one right angle. The conclusion here is it has no more than one right angle. So based on step number 1, we need to negate the conclusion and we need to assume that this is true. And the assumption will be a triangle is a right triangle and it has more than one right angle. For step number 2, we need to give the reason from the assumed statement with statements given in the theorem until a statement that contradicts a known fact is obtained. So we need to recall that the sum of the angles of a triangle is 180 degrees. Therefore, for giving such reason from the assumed statement, we can contradict if 2 angles of the triangle are right angles, then the third angle must have a measure of 0 degree. Since the sum of the measure of the 3 angles of a triangle is 180 degrees, this contradicts the definition of the measure of an angle which must be greater than 0 degree. For step number 3, we need to cite the assumed statement must be incorrect and that the conclusion of the theorem must be true. Therefore, the assumption is false and the conclusion of the theorem is true. That is, a right triangle has no more than one right angle. How to answer your learning activity sheet? Let's say angle H is not an acute angle. So, in writing informal proof or indirect proof, or in other known as proof of contradiction, the first step is we need to assume, wherein we need to negate the conclusion of the theorem. So, in this statement, let's practice negating the conclusion or the statement. So, angle H is not an acute angle. The negation of this statement is angle H is an acute angle. So this will be our assumption. Measure of angle 1 is less than measure of angle 2. What will be our assumption? Therefore, measure of angle 1 is greater than or equal to measure of angle 2. Another, if the laptop does not work well, then it is defective. The assumption will be the laptop is not defective. Points C, D, and E are not coplanar. The assumption here is points C, D, and E are coplanar. After we've discussed indirect proof, we can now move on to formal or two-column proof. There are steps in writing formal proof. First, write the theorem or statement to be proven. Step 2, draw a sketch or figure for the statement. Step 3, list the given and the statement to be proved. Step 4, plan the proof that includes the definitions, postulates, and theorems. Step 5, design the two-column proof that contains the statement and the reasons. Let's start with step 1. Definitions and their if-then forms. Betweenness. If points A, B, and C are collinear and B is between A and C, then AB plus BC equals AC. And here is the figure. We have points A, B, and C which are collinear, and B is actually between A and C. Therefore, AB plus BC is equal to AC. This is the definition of betweenness. Midpoint. If points A is the midpoint of segment BC, then AB is equal to AC. And here is the figure. Segment bisector. If segment AB bisects segment PQ at B, then segment PB is congruent to segment QB. Here is the illustration. We have segment PQ, wherein segment AB bisects segment PQ at B. Therefore, the segment PB is congruent to segment QB. We can use protractor. Let's say right angle. If the measure of angle BAC, or if angle BAC is a right angle, then the measure of angle A is 90 degrees. Here is the illustration. We have A, which measures 90 degrees. This is an illustration of a right angle. If angle A is a right angle, then segment AB is perpendicular to segment AC. This symbol is read as is perpendicular, the inverted T. So here is the illustration. AB, segment AB is perpendicular to segment AC. Acute angle. If angle A is an acute angle, then the measure of angle A is less than 90 degrees. Less than o mas maliit sa 90 degrees. Obtuse angle. If an angle is an obtuse angle, then the measure of angle is greater than 90 degrees. Greater than o mas malaki sa 90 degrees. Complementary angles. If angle A and angle B are complementary angles, then the measure of angle A plus the measure of angle B is equal to 90 degrees. Some examples of complementary angles. The sum of the two angles should be 90 degrees. Take note of this. 10 degrees and 80 degrees, 40 degrees and 50 degrees, 45 degrees and 45 degrees, 1 and 89, 30 and 60, 33 and 57, 5.5 and 84.5, 29.1 degrees and 60.9 degrees, 25 degrees and 65 degrees. Supplementary angles. Angle A and angle B are supplementary angles, then the measure of angle A. When we say supplementary angles, their sum must be 180 degrees. This should be 180 degrees. Sorry for typo error. Okay? So 180 degrees. Some examples of supplementary angles. Take note, the sum of the two angles should be 180 degrees. (10 degrees and 170 degrees, 50 degrees and 130 degrees, 90 degrees and 90 degrees, and so forth. Linear pair. If ray PQ and ray PR are opposite rays, and ray PT is any other ray, then angle QPT plus angle TPR form a linear pair. So this is line QR with point P. P is the common endpoint of ray PQ and ray PR. So they are opposite rays. And we have ray PT, which is other ray. Then the angle form, which is angle QPT plus the angle TPR, form a linear pair. Angle bisector. If ray AD bisects angle BAC, then angle BAD is congruent to angle DAC. Congruent segments. If segment AB is congruent to segment CD, then AB is equal to CD. Or, if AB is equal to CD, then the segment AB is congruent to segment CD. Congruent angles. If angle A is congruent to angle B, then the measure of angle A is equal to the measure of angle B. Or, if the measure of angle A is equal to the measure of angle B, then then angle A is congruent to angle B. Okay, let's proceed. After we discuss, we present the different definitions needed in proving. We can now proceed to the properties of equality. So here are the following properties of equality: reflexive, symmetric, transitive, addition, subtraction, multiplication, division, substitution, and zero product. We also have the law of substitution. So the law of substitution, if A plus B is equal to C and B is equal to X, then A plus X is equal to C. We also have postulates. Let's have angle addition postulate, or AAP. If T is the interior of angle PQR, then the measure of angle PQR is equal to the measure of angle PQT plus the measure of angle TQR. Example, we have point T here, which is interior and under angle PQR. We can now say that the measure of angle PQR is equal to the measure or to the sum of the measures of the two angles, which are PQT and TQR. PCAC postulate. So this is if line 1 is parallel to line 2, then angle A is congruent to angle B. So the two lines, the two vertical lines there is read as is parallel to. Angle A and angle B are corresponding angles. Supplement postulate. If angle 1 and angle 2 form a linear pair, then angle 1 and angle 2 are supplementary angles. When it comes to theorems. So vertical angle theorem. So if angle 1 and angle 2 are vertical angles, then angle 1 is congruent to angle 2. Supplement theorem, or ST. If angle 1 is congruent to angle 3, angle 1 and angle 2 are supplementary angles, and angle 3 and angle 4 are supplementary angles, then angle 2 is congruent to angle 4. Complement theorem. If angle 1 is congruent to angle 3, angle 1 and angle 2 are complementary angles, and angle 3 and angle 4 are complementary angles, then angle 2 is congruent to angle 4. PSSIAS theorem. If line 1 is parallel to line 2, then angle A and angle D are supplementary angles, and angle B and angle C are supplementary angles. Angle A and angle D, B and C are same side interior angles. Some of the measures of the angles of a triangle theorem. We already know this. Exterior angle theorem. So the measure of angle ACD is equal to the measure of angle A plus the measure of angle B. Okay, let's do the practice. We already have the knowledge of the different kinds of definitions, properties, postulates, and theorems needed in writing proof. This will be used as our reasons, okay, for our two-column proof. So let's start with this. We have a given AP is equal to BQ, and we need to prove that AB is equal to PQ. So we have this two-column proof. One column for statement and another column for reason. So first thing to do, we need to Okay, so remember, proof is a chain of true statements, and we need to start our proving with the given. So the first statement will be AP is equal to BQ, and the reason here is given. For the second statement, so based on the figure, we actually observe that AP is just equal to BQ. We can now say for the second statement that AP is equal to AB plus BP, as well as BQ is equal to BP plus PQ. And the reason for this is the segment addition postulate. And for the third statement, based on the second and first statement, we can conclude that the AB plus BP is equal to BP plus PQ by substitution. And lastly, since we're gonna prove that AB is equal to PQ, we can have that AB is equal to PQ by subtraction property of equality. So this is how to prove the given to prove that AB is equal to PQ given AP is equal to BQ using two-column proof. Another practice. Let's say this one. Okay, the given is PA is equal to TH, and we need to prove that PT is equal to AH. So same, we need to start from the given. So the statement will be PA is equal to TH, and the reason for this is given. For the second statement, we can have PA plus AT is equal to AT plus TH. And the reason for this is addition property. And for the third statement, we can conclude that PT is just equal to PA plus AT, and AH is equal to AT plus TH. And the reason for this is segment addition postulate. And lastly, we can prove that PT is equal to AH by substitution. So there are different techniques on how to prove a certain theorem, okay, or a certain statement. Make sure that the statements are in logical order since a proof is a chain of true statements.